Okay. Hi everyone. Can you hear me okay? Okay. If you need me to speak a bit louder, just someone yell at me and that's fine. First of all, this is a very weird feeling just talking to myself. I don't hear any loudspeakers, so this is a first for me. But thanks for being here. Thanks for sticking out so long in the conference. So my name is Toma Puljak and I'll do a deep dive into development environment configuration standards. A bit about myself. I'm 23. I've been active as a software developer for about 7 years now. I'm a software developer and advocate at Daytona, where I'm part of the core company team. 2 lines about Daytona. Daytona is an enterprise-grade GitHub Codespaces alternative that provides you with scalable and secure standardized development environments that you can deploy to any cloud provider that you want. It's self-hosted and it works with any Git provider as well. First, another mention, so if you want to win a monitor at our booth after the talk, you can just scan the QR code and you can go home with a monitor. So let's get into the talk. First, we'll reiterate on the idea of what is a development environment. Most of you here probably think you know what a development environment is, but we'll just touch base for a few minutes. Then we'll see what even we need to standardize in our development environments. Then we'll talk about the most popular standards that are used to standardize them, and then how to even choose a standard that's a fit for yourself, for your team, for your company, and for your projects. First, before we start, I want to also touch on a concept that's gaining more and more traction in Devworld, and that's the inner versus the outer loop. So the inner loop is something that encapsulates the whole development process. It's all of your development tools such as debuggers, Git, Vim, ID, support, whatever, LSPs, and your runtime for the language itself. Some personalization stuff as well. And then the outer loop of the story is everything outside that, but the minimal set of functionality you need to package your application to deployment. So no debuggers, no Git, no nothing, just your code, the minimal set of dependencies, and the packaged app. This concept will be important for some of the tooling that I'll mention a bit later. So what even is a development environment? So a development environment first has to have access to your code, some source code that's hosted wherever. Then you need to have some project libraries. For example, I don't know, you need to install Moment from JS, you need to install any, I don't know, Java dependencies, C# dependencies, and so on. Then you need some system-wide packages. For example, I don't know, you need Git while developing, you need some AWS CLI tool for some CLI stuff, or any other system-wide package like curl or Vim or zip or whatever. Then you need to have an IDE. So the IDE might seem like a given or something trivial, but I know it takes time to configure the IDE to your liking as well. I don't know, configuring settings, extensions, even the theme, it all takes up some time to configure for your most productive workflows. Then lastly, we need some compute resources. We need the project to run on some compute, on some machine. For example, you need at least 2 gigs of RAM to run your project. That's a compute resource requirement. And I know for a fact that it's a pain to standardize all of this. I know for a fact we all hate going through this list and configuring it for every project that we onboard ourselves to. Or for example, some legacy code breaks and now you have to download some legacy binaries that are not anywhere online. It's on some USB stick in the company and you need to fix it up as soon as possible. And that's where standardized development environments, or so-called SDEs, come into play. SDEs will help us eliminate all of these headaches and provide you with an environment that's always ready to code and tailored to that specific project. The question now stands as to what even needs to be standardized, because some things already are. So I'll assume that your code and your project libraries are already covered. So your code is, let's say, standardized inside a Git provider, for example, GitHub, GitLab, whatever. Then you have project libraries that are also handled by your code, specifically your package manager for the language that you're using. So for example, yarn and npm, pm for Node, or for example, NuGet with C#, Java has Maven or Gradle, and these managers such as that. That's covered, that's all. We take this for granted because every language has standardized, let's say, project libraries. The hard part of the story is the system-wide packages, your IDE, and the compute resources. It's very hard to standardize, for example, which version of an OS dependency you need for a project. You can't really standardize that in a way that you can standardize your project dependencies. And now I'll show you how you can standardize all of this through code, and you can think of this as development environments as code. So we will define everything our development environment needs through code with just a few simple files and a standard that we will choose at the end. So let's get into it. Let's get into these development environment configuration standards. First, I can't really talk about any kind of standardization without mentioning Docker, of course. And I know probably most of you here heard about Docker or are using Docker actively in your workflows for development or for production deployments. And Docker has been used for development more and more as well. So for example, this is some simple Docker file that describes a Node.js environment. It has some minimal set of tools to describe a development Node.js environment. So you see we have git, vim, sudo, curl, build essentials, and then we have Node itself. We set the user and so on. Docker, of course, can be used in the Docker Compose scenario as well, where you have the application, the API, database, cache store, whatever. And Docker is being used more and more for development because we all love what it brings to standardizing our deployments, so we need to standardize our development environments as well. But while Docker might be great for standardizing, I don't know, which system-wide packages you need, but what about the IDE customizations and what about compute resources? You can't really build compute resource requirements into a Docker file. That's where we can take a look at a couple of standards that are also based on containers, and that's dev container and dev file. Dev containers are an open source standard that is created by Microsoft. It's fully open source. It has an open source CLI as well, which you can take a look at GitHub and download it for free and start using it right away. Dev containers have a very, as you can see, developer-friendly JSON schema. It's really easy to pick this up. It's just a couple of required configuration properties inside a JSON file, and you're good to go, and you have a standardized development environment. As you can see, dev containers lean into Docker as well. You can specify a Docker Compose file, a Docker file, or directly an image you want to build from. And also you can specify some other stuff, for example, the remote user, or for example, a post create command, which will run directly after your development environment is created. Also, with dev containers, you can customize the IDE specifically for that project. So for example, in this example, we want to set some settings inside VS Code. We want to download some extensions in VS Code, and all of this will be handled automatically when you enter the environment using VS Code. Of course, you can define this wherever you run dev containers. So for example, locally in local desktop VS Code, in the browser using browser VS Code, or JetBrains IDEs as well. Customizations are very, very flexible when using dev containers. Another feature that's really cool about dev containers is features. And features allow you to build on top of the base container with just a few simple scripts that are configurable for your project as well. So in this example, you can see that we are installing ZSH, configuring the username, and we're also downloading Rust and all of its development dependencies. The important thing here is that these scripts or features are executed on top of your container. This means, for example, you can reuse the exact same container configuration for deployment and then build on top of that for the development, add debugger support, add ZSH, Git, Vim, whatever. And lastly, dev containers allow you to define host resource requirements as well. So for example, this environment needs 2 CPUs, 4 gigs of RAM, 32 gigs of storage, and a GPU to run. When you define this, you're sure that all of the environments will be able to run the project actually. There will be no throttling, no overheating, no whatever. You know this is the minimum to run your project in any environment. Dev containers are tightly integrated with VS Code as well. You can download the extension right now. You can just run the command reopen in container, and that will build the dev container locally and attach VS Code automatically into the container. Then you can get a list of your dev containers. You can enter any of them, not just the main container. You can get the logs. You can stop them, start them, whatever you want. It's really so flexible and very tightly integrated into the IDE itself. But for the JetBrains lovers, it's not all grim. JetBrains, of course, has a dev container package as well, where you can open the dev container JSON file, just click a button and open up the dev container in the exact same way. What's important here is that you get the underlying container exactly the same, whether it's JetBrains or VS Code, but you leave the IDE as a choice to the developer itself, so anyone in the team can work with whatever they want while working. So that's dev containers. It's an open source standard that is container based. It has great IDE integrations that you can use right now. And it's very easy to learn, very easy to pick up. It has a lot of great documentation and examples provided by Microsoft and other open source contributors as well. And now for DevFile. DevFile is managed by the Cloud Native Computing Foundation, which manages a lot of other open source projects like Kubernetes, for example. And DevFile is a standard that's implemented in YAML. And as you can see, it's also container-based. You can define a container for the development environment, define the image, some endpoints, mount some sources, and so on. DevFile also advocates its ecosystem. It's one of the big things pushing DevFiles forward. They advocate the ability for people to write and publish DevFiles into public and private registries. So for example, you as a company can maintain a list of DevFiles inside the private registries and then just reuse them for existing projects. This gives you a lot of control from a team perspective, from a company perspective, or you simply just want to borrow some DevFile configuration from the public registries. DevFile is also very tightly integrated, or sorry, the most popular actually DevFile CLI tool is called Odo. And Odo is a CLI tool that leans into the inner and outer loop part of the, let's say, paradigm of this whole thing. The inner loop story with Odo is just running the CLI command called Odo dev. This will run the DevFile configuration in development mode. You will get the entire, let's say, DevFile experience, all the packages, all the unnecessary stuff for production. So again, debuggers, Git, Vim, curl, whatever you don't need in production. But then when you're done, when you've developed the code, you can just run Odo deploy and reuse the exact same configuration of the DevFile and push it to production without the all unnecessary dependencies that your development environment has. This is amazing because you get to reuse and standardize both the processes, both the inner and outer loop. Of course, DevFile and Odo have great VS Code integrations as well. You can use the OpenShift toolkit in VS Code to manage your dev files, to create one using a graphical interface, or to manage your workspaces as well. Also, JetBrains integration as well. There's no beef when talking about these standards. JetBrains and VS Code is supported both ways. And also, I wanted to touch on an important aspect of DevFiles as well. So, if you Google DevFile and go to their documentation page, they say they are a Kube native API for managing remote cloud workspaces. This means that DevFile leans heavily into Kubernetes. It's actually a great standard to choose if your company or project already uses Kubernetes, because as you can see, it gives you full control over all the Kubernetes resources. You can write manifests directly inside the DevFile. This means that for any, I don't know, DevOps, it's really easy to pick up DevFiles and to just create manifests specific for development. DevFile is natively supported in Eclipse-J and the OpenShift toolkit as well, and you can use them today to create these cloud native, cloud remote workspaces with this Kube native API. So that's Odo and DevFile. They're, again, open source, Kube native. They have a great ecosystem story, and they lean into the inner and outer loop story by design. And now something totally different, something that's not tied to containers at all, and that's Nix. And Nix is not like the other standards. Nix declares itself as a purely functional package manager. What this means is that packages inside Nix are treated as values in a functional programming language. This means that Nix builds all the dependencies and packages in complete isolation, and they are immutable once they're built for the first time. This is an example of a directory of a Nix package. As you can see, the first part of the package itself is a long hash. And this hash represents the dependencies of the package itself. So this means that Firefox, for example, has, I don't know, 5 dependencies. If dependency number 2 changes, the cryptographic hash of this package changes. And this means that whenever you download this version of Firefox, you know it works because it was built in the exact same way every single time you download it. There's no breaking anything when working with packages such as this. Also, Nix allows you to create what they call ad hoc shell environments. So for example, this is a simple way to create an isolated shell that has Git, NeoVim, and Node.js installed. This will give you the opportunity to test your code really easily in different environments. So for example, will my code break if I use Node version 4 or Node version 6, or will it break if I do have Git installed or I don't have Git installed? Nix shell can really easily allow you to test your code in different, let's say, OS package scenarios. Also, there's the shell.nix file, of course, because I said dev environments as code. You can define all of this inside the Nix file, where you can list dependencies. For example, this is a bare minimum example of a Node.js environment with Yarn and Git installed. And Nix can do a lot more than just manage your dependencies. If you want, you can take a look at the docs. They have a lot of documentation about the language itself and the paradigms behind the whole purely functional package manager stuff. But that's not all with Nix, and you're gonna hold for a second while I drink to build suspense. Okay, that's not all with Nix. There's something else with Nix that's very, very special, and unlike the other standards, we just give you a development environment, and that's it. With Nix, you can use NixOS. And NixOS is a way to standardize your entire operating system. By entire operating system, I really mean the entire operating system. So in NixOS, everything is defined through configuration files. Down to the bootloader itself, the file system does which services to enable or disable. Everything is defined through configuration files. And once Nix is built, it's completely standardized and completely immutable and secure. Why is it immutable and secure? Because you can't rebuild Nix, you can't inject anything into Nix without modifying the file and rebuilding the OS. For example, nothing malicious can be injected inside your packages because it has to be first injected into a file, then your OS needs to rebuild, and then you would notice somewhere in between that something's happening that you didn't want to. Also, something that's very cool about NixOS is the atomic upgrades part of the story. So, with NixOS's CLI, when you upgrade your OS, there's no chance, there's actually zero chance you end up in an unusable state. A kernel or version upgrade can't break your laptop. There's no chance you have to reinstall Linux for the 5th time because you didn't take care of some stuff while updating, or you don't have to wait for the entire installation to finish. You can just drop it in the middle, or you don't have to be connected to the internet. So it's very, very cool, because what happens is when a NixOS upgrade breaks, you just get reverted to the last state in an instant. Every single NixOS upgrade is actually stored inside your NixOS, and you can easily roll back to any version. This also gives you the ability to, again, test out your code in different, for example, legacy scenarios. So for example, if you manage your NixOS installations for a couple of years, you can really easily revert to a state where NixOS had, I don't know, again, Node 6 or Node 8 or PHP 1 or whatever. You can really easily test your code in a lot of different scenarios using these features. And that's NixOS. So again, it's open source. I really love open source standards, if you can tell. What's cool about open source standards is that they give you the ability to work on the standard while working inside the standard. So for example, if you want to fork the dev container CLI, you need to first build a dev container, enter the dev container, and then work on the dev container specification. So Nix is a functional package manager. As I said, it is a fully secure OS, far more secure than Linux, for example. It has atomic upgrades. There's no chance you end up in a broken kernel state. You can really easily roll back to old installations. And that's the NixOS part of the story. And now the most important question is how to choose. This, of course, depends on your team, on your preferences, on the projects that you are running, on the machines you have available. So, for example, let's take a look at a table like this. So, if you want to, let's say, container-based standard, if your application is already containerized, it might make sense to go for dev file or dev containers. If you want great IDE integration, you can get any three of them. If you want, for example, something that's kube native, if your project is already deployed via Kubernetes, if you have a DevOps that loves Kubernetes, then dev files might be the way to go. Or if you want full OS level security, you want that reproducible OS functionality, then Nix is the obvious choice. The thing here is that you don't really have to, let's say, wrap your head around which to choose. The important thing is to just choose whichever you want. How you implement it in the end is not really important. What's important is that you understand that standardizing your environments will bring a lot of, let's say, a lot more efficiency to your team. There will be a lot less frustrations while onboarding, for example, juniors to the team, while switching laptops, while switching projects, working with legacy code. So choosing a standard is, let's say, the easy part. Just choose one and the standard will take care of the rest. Of course, one last Daytona plug. We currently work with dev containers. We plan to support NixOS and dev files as well, but we really believe in this SDE cause, and we really believe that the right way forward is to eliminate all the frustrations while working with standardizing your development environments. If you have any questions, you can reach me via email or Twitter, or actually come to our booth and head there for a monitor if you want. So thanks for being here. Thank you very much.